nth term of a geometric sequence is determined by the formula t sub n is equal to t sub 1 times r raised to n minus 1, where t sub n is the nth term, t sub 1 is the first term, r is the common ratio, and n is the position of the unknown term. If the first term of the geometric sequence is not given, the nth term is determined by the formula t sub n is equal to t sub m times r raised to n minus m, where t sub n is the nth term, t sub m is the given term, r is the common ratio, n is the position of the unknown term, and m is the position of the given term.
Let us determine the general term of the geometric sequence 2, 8, 32, 128, and so on. Now, since we are given only the first 4 terms of the sequence, let us determine first the common ratio by dividing any 2 consecutive terms. So we have here our first term, which is 2. Our second term is 8. Our third term is 32. And our fourth term is 128. Now, to determine the common ratio, we are going to divide the second term by the first term. So that would be t sub 2 over t sub 1. So r is equal to, substitute our second term, which is 8 over 2. So r is equal to 4. So our common ratio is 4. Now let us substitute the values now to the nth term or the formula for the nth term of a geometric sequence. By the way, you can compute for the common ratio by dividing also the third term by the second term or the fourth term by the third term. So we now have t sub n is equal to t sub 1 times r raised to n minus 1. Substitute the value. So we need t sub 1, which is 2, and r, which is 4. So we have t sub n is equal to 2 times 4 raised to n minus 1. So this is our general term. Let us proceed to the next example. Okay, we are given the first term, which is 3, and the common ratio, which is negative 2. So this one is very easy because we are going to substitute only the given values to the formula for the nth term of the geometric sequence. So we have t sub n is equal to t sub 1 times r raised to n minus 1. Substitute the given values. We have t sub n is equal to 3 times negative 2 raised to n minus 1. This is our general term. Do not forget to enclose the ratio in parentheses. Now let us go to the third and last example. So we are given the first term, which is 2, and the sixth term, which is 486. Now let us compute for the common ratio using the formula that I have given you last week. So that is r is equal to n minus 1 root of t sub n over t sub 1. So since our last term or the upper extreme is t sub 6, that means our n is equal to 6. Now substitute the given value. So we have r is equal to 6 minus 1 root of 486 divided by 2. Let us simplify the equation by following the order of operation. So since 6 minus 1 is the index of the radical, we are going to subtract 6 and 1. So 6 minus 1 is 5. And then let us get the quotient of 486 and 2. So that is 243. After that, get the fifth root of 243. So the fifth root of 243 is equal to Okay, 3. Now, if you don't know how to get the fifth root of 243, you can use your calculator. And if you don't know how to use your calculator, do not hesitate to contact me. Now, let us substitute the value. So, we have t sub 1, which is 2, and the common ratio, which is 3. So, we have t sub n is equal to t sub 1 times r raised to n minus 1. We have t sub n is equal to 2 times 3 raised to n minus 1. Now, this is our general term.